Hello, my name is Omar Osama. I'll be talking about the impact of a jet in controlled volume lab. Uh, these are the elements I'll be talking about. And for introduction, engineers and designers use the momentum equation to accurately calculate the force that moving fluid may exert on a solid body. For example, in hydropower plants, turbines are utilized to generate electricity. Turbines rotate due to force exerted by one or more water jets that are directly attached onto the turbine's vanes or buckets. The impact of the water on the vanes generates a torque on the wheel, causing it to rotate and to generate electricity. The objective of this experiment is to investigate the reaction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat plate or a curved surface, and to compare the results from this experiment with the computed forces by applying the momentum equation. Now, for the methodology, the momentum force is determined by measuring the forces produced by a jet of water impinging on solid, flat, and curved surfaces, which deflect the jet at different angles. Before the experiment was carried out, a quick inspection was performed to ensure that the unit is in proper operation condition. First, a hose connection was made and is connected to the nearest power supply. Then the discharge pipe was opened. When assembling the deflector, the three screws on the cover were first loosened and the cover was removed together with the lever mechanism. A plate deflector was then fitted. After that, the lock nut on rod was tightened and the cover um, was screwed back onto the vessel. The pointer was set to 0 using adjusting screw before placing any loading weights on measurement system. Desired loading weight was 0.2 Newton, 0.3, 1, 2, and 5 Newton were then applied. The main cock was closed and the pump was switched on. The main cock was closed and the pump was switched on. The main cock was carefully opened until the pointer is on 0 again. After that, drain cock was closed and the flow rate was determined. Time required for the level in the volumetric uh, tank to rise from 20 to 30 liters was recorded. Then the pump was switched off and the drain was opened. These steps were repeated for hemisphere and slope deflectors. All results were recorded and tabulated. Now, the parts used were hydraulic bench deflectors, which had plate, hemisphere, and slope, and then the water jet apparatus, weighing tank, stopwatch, and a loading weigh. Now, as you can see here, the results. We have the results for the plate, and then after that, the hemisphere and the slope. Now, these were the formulas used to calculate the force on the plate. We have this equation, the p cube power 2 over a. For the hemisphere, it's 2p cube power 2 over a, and for the slope, as shown here, is p cubed power 2 cos power 2 45 degrees over a. The formula used to calculate the percentage of error is the calculated force minus the measured force over the measured force. Now, for the discussion, for this experiment, we used 10 liters of water and a nozzle of diameter 10 millimeter. Based on the time recorded and the information above, we are to calculate the calculated force, FTH, and the percentage of error. First, we convert the unit of the flow rate, Q, from L per minute to m3 per second for the ease of calculation. For the calculated force and the percentage of error, they are calculated according to the formulas mentioned before in the previous slide. In this experiment, when the measured increased, the time needed for the level in the volumetric tank to rise from 20 to 3 liters decreased. This results in a decrease in the flow rate. When comparing the three types of deflectors, the flow rate for the hemisphere is found to be the lowest. The percentage of error ranged from around 14% to around 470%. Some of the percentages of error are very large due to several errors made during the experiment. One of the errors may be the error made during setting the pointer. The pointer may not precisely set to 0 due to the parallax error. Another possible error is the error made when recording the time. Other than that, error made when adjusting the main cock is also possible. The main cock may not properly open, causing the pointer not exactly at zero, to be not exactly at zero. As a conclusion, the calculated force is correlated with the measured force. Both of the forces will have directly proportional relation. Theoretically, the calculated force should be the same as the measured force. However, this cannot be achieved experimentally due to the errors made during the experiment. From this experiment, the flow rate of the hemisphere is found to be the lowest and thus require a longer time for the volumetric tank to rise from 20 to 30 liters. Thank you so much. That's it from me.